Good morning, everybody. Today we are discussing the next topic of the stereochemistry, that is the prochiral center. So till this portions we have discussed how the chirality arises in an organic compound, and chirality means if a carbon is substituted by a four different substituent, then the molecule is non-superimposable on its mirror images, so it is chiral. So here we are discussing the prochirality. Pro means before. That means consider a molecule like carbonyl group. We know that the carbonyl group is not a chiral center because the carbon is doubly bonded to the oxygen atom. So that's why there are only the two substituent are the different, and the remaining two valency of the carbon is doubly bonded to the oxygen atom. So the carbonyl group is not a chiral center, but we can convert the carbonyl group into a chiral center by adding a nucleophile. So if you are adding the nucleophile on the top face of the carbonyl group, we will get the first enantiomer. So that is shown in the top of the slide. And if the nucleophile, that is represented by the blue nucleophile, blue color, and if the nucleophile are attacking in the bottom face of the same carbonyl group, that is shown by the green color, we will get the next enantiomer of the same product. So depending upon the attack of the nucleophile, or depending upon the side of the attack of the nucleophile, we will get the two enantiomers, and in this process the carbonyl group is converted into a chiral center. So that's why the carbonyl group is known as the prochiral center. Pro means it is before, chiral means it is a chiral molecule. So prochirality means the before the chirality. That means carbonyl group, actually it is not a chiral center, but we can convert it into chiral center by adding the nucleophile on the top or in the bottom. So if depending upon the attack of the nucleophile, we can get the either it a D variety or it is a L variety. So the prochirality definition is very important. Definition is that carbonyl group is not a chiral center actually, but it can be converted into chirality as the reaction proceed. Now we have now discussing the two important term, that is the pro R and pro S. As we discussed earlier, we can convert a prochiral center into a chiral center. If a nucleophile attack in the top of the face, and we have to assign the remaining, or we have to assign the product of this reaction by using Cohn-Ingold prolongs rule, then if the configuration of the result is a R variety, then we call the starting material as pro R. For example, consider a propionic acid. We know that the propionic acid containing two hydrogen atom. If we are substituting one of the hydrogen atom, then that means Hb or any of the substituent, then we will get the resulting compound like this. And if you are arranging the substituent R, and if you are giving the priority to the substituent, and note that the rotation of that substituent, if it is a clockwise direction, then we call it as pro R. And consider the other product, that is the pro S. So pro R, the difference between pro R and pro S is that if a nucleophile attack a prochiral center in either in the top or the bottom face, if the nucleophile attack in the top phase, and we will definitely get a product, and we have to assign the corn in priority of the substituent according to the corn in God prolongs rule. If the product is a R configuration, then the starting material we call it as Pro R. If the product is a S variety, then the starting material we call it as Pro S. So that is the difference between Pro R and Pro S. Then we have another term, that is Si and Re. So Si means, see here, this is a carbonyl aldehyde group, and if the nucleophile attack in the right hand side, and we will get the R configuration as the product, then we call that phase of the attack of the nucleophile as Re phase, really Re phase. Then if the nucleophile attack in the left hand side and the resulting product is a S variety, then we call this phase of the carbonyl group as Se phase. I hope that you understood the concept of the pro-chirality and pro-R and pro-S and Si phase and Re phase. Thank you.